Hello, everybody. My name is Todd Muirhead, and today we're going to be talking about some work that we did with Oracle VMware Cloud Solutions that was recently published in a white paper.
Yeah, thanks, Todd. I'm Bob Goldsand. I'm with Strategic Ecosystems and Industry Solutions Business Unit, a mouthful. And as you say, we've worked a lot together on enterprise solutions. This is a pretty exciting project we just completed. Four tech powerhouses came together on this project, being Oracle, AMD, Deloitte, and ourselves. And as you know, we have a great multi-cloud story, which allows our customers to kind of uniformly extend and scale their private cloud landscapes across public cloud hyperscalers. But this uniformity does kind of present a bit of a challenge. And that challenge is, how do we differentiate these solutions from each other? From an Oracle Cloud VMware solution, the answer is really pretty obvious, is that Oracle has a clear advantage when it comes to enterprise mission critical workloads. And you couple that with the fact that customers have been running Oracle on vSphere successfully for well over 10 years. Collectively, we didn't want to publish a architecture type paper. Instead, we wanted to collect actual data. So again, we partnered with all of these companies. And so this paper talks about the results and much more when it comes to running enterprise workloads in the public cloud.
Yeah, so it was really great that we got to do some tests on the actual systems.
Absolutely. So the question is, why OCVS, and why is that? Both of us have spent the better part of our VMware careers convincing customers and the industry that enterprise workloads run just fine on our platform. And we have authored many best practices, deployment guides, knowledge base articles, etc. on this topic, covering transactional workloads, analytic workloads, in-memory workloads, telco, media, and entertainment workloads. For any of these workloads, it's critical to follow the technical documentation and guidance when configuring your cloud landscape. And with OCVS, Oracle grants full control to the customer. So you can set up your public cloud identically to your private cloud. The ability to have your public and private cloud configured identically essentially brings about true zero refactoring. And this is so critical when it comes to performance. If a customer can't access certain BIOS settings, host settings, or VM settings, then the customer may encounter performance issues, and they may not be able to achieve their enterprise service level workloads.
Right. So when you say full customer control, what that means, and you basically said this already, is that they have access to all the settings, including the BIOS settings for the server, all the settings for vSphere or vSAN, or all the different components. Now, it does get deployed with a set of default settings, which are best practices for kind of a generic environment. But to get down to the best settings for specific applications, like you pointed out, sometimes you need to go in and access these settings.
Especially now that repatriation of workloads is becoming more and more common. Performance surprises are a major factor in why workloads are being repatriated, back to the private cloud. In this paper, we kind of proved that performance is not an issue with OCVS.
Right. Yeah, we show that performance is essentially the same, and I'm going to show a couple of slides in a little bit to put a little more detail on that.
And the other thing, around Cloud Smart is, for this project, we benchmarked Oracle databases as well as SQL Server databases. And the purpose for both benchmarks was to prove customers can run any enterprise workload on OCVS. So although, again, we have a great multi-cloud story, you also have to be cloud smart. If you can consolidate workloads onto fewer clouds rather than introducing latency across multiple clouds, then OCVS may be the best option for you.
Yeah, so as this slide shows, one of our main goals in testing was to show that whether you're running your workload on-prem or in the Oracle Cloud for VMware Solutions, or OCVS, you get the same performance. So what we did was we tested with servers that were essentially the same, both on-prem and in the Oracle Cloud. And we were able to show that both with SQL Server and Oracle, we got essentially the same performance. There's a little bit of delta here, and that's due to the OCVS instance having slightly better storage than what we were able to get on-prem. So, Bob, so why AMD?
When you think about VMware vSphere, it's unquestionably the best in breed when it comes to hypervisors, but we are continually making innovations to make our platform better and better. And AMD's EPYC processors, this is a great example of what we do. I mean, we leverage AMD's architecture, and fundamentally, you just can't keep adding more and more cores without experiencing contention at the last layer cache level. So AMD has come up with an ingenious way to increase core count and performance.
Basically, what AMD did was to create multiple last level caches within each processor. Whereas prior to the EPYC, it was traditional that you just had one last layer cache per socket. So now they have multiple. So you kind of end up with multiple areas of domains of compute and cache within each socket now. And so what we did was we optimized ESX scheduler to be aware of that so that it can make more intelligent decisions when scheduling, and then in turn it is more efficient and you get better performance. We have a way to be able to enable this new scheduler optimization and disable it. So the current default starting in vSphere 7.02 is to have it enabled. So if you're running on an AMD processor, you get this. But for our tests, we went in and disabled it, so turned it back to the old style of scheduling to see what the performance benefit is that we were gaining. So in this performance test, we were trying to show, like I just talked about, how with the scheduler enhancement with AMD, which is the default, we're getting an additional performance boost of about 5 to 10%. So this is a performance boost just from the scheduler enhancement. No other changes were made, and we're able to get additional performance out of the same box just with taking advantage of the scheduler enhancement, basically being smart and able to know where to schedule things more efficiently.
Well, Deloitte was also an integral part of this project as well, and we all know about Deloitte's strong advisory services, their successes and capabilities when it comes to cloud computing. But I wanted to highlight a technical project we did with Deloitte, and it's covered in depth in the white paper. And this was another project that you and I initiated around NSX data center. And essentially what we wanted to do was quantify the performance benefits of NSX when it comes to enterprise applications. And at a high level, NSX eliminates network hairpinning, which is the unnecessary network latency associated with traversing the virtual and physical layers. So in this test, and again, it's highlighted in the white paper, so you can read more about it, and we'll talk about this in our session. We used an Oracle database, and we showed that data loads ran up to 1x to 2x faster. And we published the blog, and we got strong support from our executives. But they did say that we needed to have a third party validate these results. And literally within hours, I received an email from Deloitte saying, they read our blog, the results look great. Can we do an independent validation of your study? So they did, and used a slightly different benchmark technique, but they reported either better performance than we did. It was due to the benchmark they did, but 4x to 8x or 2x to 5x, still significant performance benefits. Also, in the white paper, in order to expose these optimizations associated with the elimination of network hairpinning, we use ARIA operations for networks. And we outline one of the many techniques to kind of expose these optimizations with ARIA by accomplishing discovery and dependency mapping. So again, this is in the paper, but bottom line, this was the perfect message for Deloitte to deliver. And it's right in their wheelhouse because it kind of elevated the NSX story out of the infrastructure and into the C-suite. because performance matters to any enterprise.
And these applications were, in both cases, the ones that we did and the one that Deloitte did, were extremely network intensive. So this highlights kind of a best case scenario for the type of performance gains that you can see with this type of elimination of network hairpinning. Yeah, so all the information that we've talked about in a lot more detail, we're going to be doing a session at VMware Explore this year in late August in Las Vegas. Me and Bob and also Oracle and AMD will be all partnering together in this session.
Yeah. And I understand Schedule Builder went live. So the title of our session is Maximizing Database Performance, Harnessing the Power of VMware, AMD EPYC Processors, and the Oracle Cloud Infrastructure. And there will be several activities around our session, as well as a white paper. Following our session, I think from 5 to 7, AMD, Oracle, VMware, and Deloitte will be hosting a happy hour. So feel free to come by and speak with us, and it should be a lot of fun.
And I'm going to put links to all this information below the video, so you can find it that way as well. All right, thanks everybody for watching, and we look forward to seeing you either in the next video or at VMware Explorer.
Thanks, Todd. Take care.
Bye.
Okay, you don't have to say goodbye, though. I mean, I still want to talk to you.